A cancer patient's white blood cell count grew exponentially after she had completed chemotherapy treatments. The equation C is equal to 63 times 1.17 raised to the D describes C, her white blood cell count per milliliter, D days after the treatment was completed. A. What is the white blood cell count growth factor? B. What was the initial white blood cell count? C. Create a table of values that shows the white blood cell counts from day 0 to day 10 after chemotherapy. And D. From the table of values, approximate when the number of white blood cells doubled. Let's start with part C. Create a table of values that shows the white blood cell counts from day 0 to day 10 after the chemotherapy. We'll use a graphing calculator as a tool. On the graphing calculator, go to y equals and enter the function. Instead of using C's and D's, we'll be using Y's and X's. So we'll have 63 multiplied by 1.17 raised, not to the D, but to the X. To create a table of values, we'll go to Table Set, second window. We'll start at 0. We'll increment by 1. And we'll let the calculator automatically fill in the values for the independent and dependent variables. Go to Table, second graph. And then look at the values in the Y column. We can see that initially the blood cell count was 63 cells per milliliter. It then increased to approximately 73.7 cells per milliliter, and then 86.2 cells per milliliter, and so on. Using these values, go ahead and create your table for part C. Now that we've created the table of values, let's go back to part A. What is the white blood cell count growth factor? Well, the growth factor is what we need to multiply the blood cell count by as the number of days goes up by 1. So we need to be asking ourselves, 63 times what number gives us 73.7? 73.7 times what number gives us 86.2? And so on. Well, in order to figure that out, we can simply take two consecutive values and divide the second by the first. So let's go back to the home screen and let's find 73.7 divided by 63. That's approximately 1.17. Next, let's take 86.2 and divide by 73.7. That's also approximately 1.17. Next, let's take 100.9 and divide by 86.2. Once again, we get approximately 1.17. If we were to continue this process, we would notice that time and time again, when we divided two consecutive cell counts, that we would get 1.17. That means that the blood cell count growth factor is 1.17. Now notice that up in our equation, the base of the exponential function is 1.17. So to answer part A, we can simply look at the exponential equation and write down the base of the exponential function. That is the blood cell count growth factor. So for A, our answer is 1.17. What was the initial white blood cell count? Well, the initial blood cell count occurs on day 0. We look at day 0 and we see that the blood cell count is 63. We could also get that from the equation. If we substitute 0 for D, we get 1.17 to the 0, which is 1. 1 times 63 is equal to 63. So our answer for part B is 63 cells per milliliter. Finally, for part D, it says, from the table of values, approximate when the number of blood cells doubled. Well, our initial blood cell count was 63, and 63 times 2 is 126. So we need to locate where the blood cell count is. Finally, let's complete part D. From the table of values, approximate when the number of blood cells doubled. Well, our initial blood cell count was 63. Twice 63 is 126. So we look down the table to locate where 126 is. Well, 126 is between 118.1 and 138.1. So that means that somewhere between day 4 and day 5 is when the blood cell count doubled.